Use a suitable normal approximation to x is a binomial with 40 trials and probability of success 0.35 to find approximations of the following. So first of all, we want to find the expectation of x, that's the mean, and that's 40 times 0.35, and that is actually 14. And then we need the variance of x, which is 40 times 0.35 times 0.65, and that comes to 9.1. So we'd use a normal with a mean of 14 and a variance of 9.1. And now, to approximate the probability of x's being 15, we would use y from 14.5 to 15.5. Remember the continuity correction. And so now you'll have a similar sort of app on whatever calculator you've got. So we're going to go 14.5 to 15.5. So whatever app you have, it's usually these things you fill in. It's usually the standard deviation on the calculators, not the variance. So remember that you need to square root the variance and put the mean in, and that is 0.1247. Correct to 4 decimal places. Okay, the next one is just x is greater than 15. And remember, because the binomial is discrete, that's the same as x is greater than or equal to 16. So when we apply the continuity correction here, we need to go for y being greater than 15.5. So we'll go to the app, and so I put in here 15.5. My upper, on this calculator I can put in infinity, but if you don't have that facility, just make sure you go to a lot of standard deviations above 15.5. So 1,000 or something like that would be perfectly okay. And we want the standard deviation, so 9.1 was the variance, the square root of that, and then 14, and that's 0.3095. Correct to 4 decimal places. And then finally, x is from 30 to 37. Now remember that means that inclusive, that's 31 to 36. So when we use our continuity correction, we're going to need y to be from 30.5 to 36.5. So again, go and find the app, and that is 30.5 up to 36.5, square root of 9.1 and 14, and that is small, 2.25 times 10 to the negative 8. Now, I'm interested to see how accurate that is. So let's actually go and look at our binomial for that. And remember, we went from 31 to 36 with 40 trials. Probability of success was 0.35. And it's not that bad. It's actually, the number part is quite different, but it's the same sort of size, times 10 to the negative 8. The actual probability is a bit more than double what our estimate's given us. And remember, we'd expect that because this n is not that big when we have an asymmetric distribution, and we're also a long way away from the mean, and it tends to get worse as you go away from the mean, especially when you've got the skewness.